Hello friends, welcome you all. So in this video, we will discuss another kind of pushdown automata, which is known as non-deterministic pushdown automata. If you can remember, in last video, we have discussed some example of pushdown automata, and all we example were kind of deterministic. And in this lecture, we will discuss now non-deterministic PDA, which is also known as NPDA. So we will discuss this NPDA, non-deterministic pushdown automata here. Now I will tell you first what is NPDA, and then I will discuss its transition function, and I will take one example language that you can accept with NPDA. So we will start with the definition of NPDA. So again, PDA, it is like, as it is PDA, so it is also a 7-tuple machine. It is also a 7-tuple machine, and tuples are exactly same as pushdown automata. So these are Q, sigma, then gamma, then delta, then Q0, then Z0, and then F. So all these tuples are there in NPDA also. The only difference between, and the meaning of all tuples is same, the only difference is there in transition function. I will discuss the transition function of NPDA here only, and remaining all tuple meaning of tuple is same as PDA, so no need to discuss it again. So I will discuss only the transition function here. And see, as PDA considers current state which comes from Q, then it also consider current input symbol along with epsilon. So I can write it like this. And then it also consider current stack top which is coming from gamma. As it is NPDA, so it will be having it will be the power set of Q cross plane closure of sigma. Plane closure of sigma. So in case of PDA or DPDA, deterministic PDA, it was only Q cross sigma star, but here it is power set of Q cross sigma star. So this is the transition function of NPDA. Now I will take one example language that you can accept with NPDA. Very common language is there, which is known as WWR. It is also known as even length palindrome. So the set of all strings of this kind, where W is any string of 0 and 1, and you can represent W as 0 plus 1 positive closure. So you can write it like this: WWR. This is one example of context-free language. One example of context-free language, and it is also known as even length palindrome. Even length palindrome. So where W is any string of 0 and 1, 0 and 1, where at least one symbol must be there in W. And WR means reversal of W. So whatever the W is, suppose 0 1 0 is there, so reversal of it would be 0 1 0 again. So this is one example of WWR. This is one example of this string of this particular language. For example, I can take one string of 0 and 1 as 0 0 1 1 0. You can consider this as W, and then WR would be 0 1 0 again. So now if you want to get this string accepted by PDA, then you need to create NPDA. Why? See, whenever we are having two consecutive symbol as same, so we can consider this as the middle of a string, or we can may not consider it as middle of a string. So we need to write one transition considering this as middle of a string, and one transition considering this is not middle of a string. So we need to remember these condition, and accordingly we need to write the transition rules. So I will tell you how to create this particular PDA and PDA. Now I will tell you the idea how to what would be the logic of NPDA here. Then I will discuss first, and then I will tell you how to create transition rules. So suppose this is your stack which is containing Z0 initially. Then for each symbol of W, we will push the same symbol into the stack. Suppose this is your string and this is the middle of string. Here I can see the string, complete string, so I can identify the middle of string. Right? Now you can see what our logic is. I will push the symbol that I'm reading into the stack till the middle of string. Till the middle of a string. Once I reach the middle of a string, I will start popping elements from the stack. And then if after reading complete string, only Z0 into the stack, then I can consider this string as accepted. So let's see how to do it. Now for this is W and this is WR. So now W here W is 0, 1, 0. So whenever I am reading W, I will push elements into the stack. And whenever I am reading WR, then I will pop elements from the stack. So now you can see if I am reading 0 here, so I will push 0 into the stack. If I am reading 1 here, so I will push 1 into the stack. I will read 0 again, so I will push 0 into the stack. Now this is the middle of a string. Now after middle of a string, I will start popping. So if I am reading 0 here, so stack top must be 0. Stack top must be 0. So I will pop it. Now I am reading 1. So stack top must be 1 always for valid string. So then I can pop it. Then I am reading 0 again. So stack top must be 0 again. So then I can pop it again. And after reading complete string, it is now reading epsilon and Z0 is in the top. So I can remove this Z0 from the stack, and this string will be accepted by empty stack. So this is the logic of this particular NPDA. Now I will show you how to create transitions to implement this logic. So again, I can consider Q0 as initial state. Q0 as initial state. So if I'm in Q0, I may read 0, first 0. This is first symbol I am reading, and that time Z0 would be on the stack top. So what I need to do? What I need to do? I need to push 1 0 into the stack. So I can write here, I will stay in Q0. I will write 0, I will push into 0 into the stack, and Z0 would be the same as it is. So this would be the transition for 0. But if first symbol is 1, then I'm in Q0. I will read 1, and Z0 would be on the stack top if 1 is the first symbol. So now I can write here, I will stay in Q0. I will push 1 into the stack, and Z0 would be as it is. So this is first 0 and first 1 I'm reading. Now if first symbol is 0 and second symbol is again 0, so what would be there? So I will read 0, and stack top will be 0 again. Stack top would be 0 again. Now I can consider this string here 0 1 1 0 0 1 1 0. So this is one valid string of this language. See, here we have 3 pairs of same symbol. This is 1 1, this is 0 0, and this is 1 1. So these three pairs are there which are having same symbol. Now, whenever we are having same symbol, then there are two possibilities. Like this may be the center of a string. So if it is center of a string, then what would be there? For if it is center of a string, then we need to change the state and we need to pop the symbol. But if it is not center of a string, then we need to stay in the same state and we need to push into the stack that symbol we are reading. So we need to write both these possibilities. So whenever we are having 0 and stack top is also 0, so we can consider it as middle of string. If it is middle of a string, then I can change my state to Q1. I can change my state to Q1 and I can pop one element from the stack. I can pop one element from the stack. Now, suppose this is not middle of a string as in this particular string. So, if it is not middle of a string, so I can stay in Q0 and I can push the same symbol into the stack. I can push 0 0. Now you can see for single combination there are two possibilities. There are two possibilities, and because of this nature, it is known as non-deterministic PDA. Now, if I am in Q0, if I am in Q0 and I am reading 1 and stack top is 0. Stack top is 0. That means two different symbols are there in consecutive location. That means it cannot be middle of element, middle of string. So I can write simply I can stay in Q0. I can push this one into the stack. So I can write like this. Now the next combination may be stack top is 0, then we have read 0 and 1 both. So now I will consider the next combination. I am in Q0, I am reading 0 and the stack top is now 1. So what would be there? I am reading 0 and the stack top is 1. That means two different symbols are there. That means it cannot be middle of a string. So I can simply push this 0 into the stack. So I can stay in Q0. I can push this 0 into the stack and 1 would be as it is. If I am in Q0, I am reading 1 and 1 is on the stack top. So now two consecutive symbols are same. Two consecutive symbols are same. So this may or may not be middle of a string. So now we need to consider both the possibilities here. So now considering it is middle of a string. So what I will do, I will change my state to Q1 and I will pop one element from the stack. Now considering this is not middle of a string, so I will stay in Q0 and I will push this one into the stack. So these two possibilities again I am having. Now we have considered all possibilities for Q0, current state as Q0. Now after reaching middle of the string, we will move to Q1. So now I will see all possibilities of Q1. So if I'm on Q1, I will read 0. I will read 0. Then 0 must be there on the stack top for valid string. So what I will do? I will stay in Q1. I will pop one element from the stack. Now, if I am on Q1, I am reading 1. Then definitely 1 must be there on the stack top for valid string. So what I will do? I will stay in Q1. I will pop one element from the stack. Now, I am on Q1. I am reading epsilon and If I'm reading epsilon, then Z0 must be the stack top only for valid string. So what I will do, I will stay in Q1 and I will pop this Z0 from the stack. So these are the different rules that you can use to implement this NPDA. So now this is how you can create NPDA. So this is NPDA for even length palindrome. Even length palindrome. Why I'm calling it even length palindrome? So now suppose if the length of W is even, then it will also add reverse of W. So it would again be even. So even plus even number is there. Now suppose length of W is odd, then the length of WR will also be odd. So odd plus odd, again we will get even number. So this is even number, even length palindrome. This is even length palindrome. So now all these rules are there, and if I'm getting any combination out of these rules, then I will consider it as invalid string. Now, whenever we are trying to get it uh, accepted, we need to check all possibilities of these two these two transitions. So I will tell you how to get this particular string accepted by this NPDA. So now this is our stack, this is our string, and according to the rules, I will tell you the transitions. Now I'm on Q0, I'm on Q0, I'm reading 0, stack top is Z0. So I have one combination like this, and for this combination I will push one element into the stack, and I'm pushing 0 here. Then I am in Q0 again, and I'm reading 1. Stack top is 0. So I have one combination I'm in Q0, I'm reading 1, and stack top is 0. So what I will do, I will push that one into the stack. So I will push that one into the stack. Now there are two possibilities. Next symbol is Q again 1. So I can have two possibilities here. It may be the center of a string. So suppose I'm considering this as center of a string. So what I will do, I'm in here Q0, and I'm reading 1 again, and the stack top is 1. So what I can do, I can consider this as middle of a string. So I can change my state to Q, and I can pop this element from the stack. That means I have considered this as middle of a string. So now I have popped. Now I'm in Q1, stack top, I'm reading 0, and the stack top is 0. So what I can do, I can stay in Q1, I can pop one more element from the stack. Now I'm in Q0, I am Q1, and I'm reading 0 again. I'm reading 0 again, and the stack top is Z0. So I do not have any combination like this. Here we do not have any combination where I'm in Q1, I'm reading 0, and Z0 is on the top of the stack. So that means this string cannot be accepted by this particular option. So I need to check this option again, this option now. So now we need to backtrack till this. We need to backtrack till this step. So what I will do, I will make it 0, 1, and here, now here I'm having this combination, so this I have tried. Now I will try this combination. So now you can see, now trying this combination we will have Q0 again, and I will push 1 into the stack, and then I will have I am Q0, I'm reading 0, and 1 is on the top of the stack. So this is the combination. So I can simply push 0 on into the stack. So I can push one more symbol into the stack here. Now you can see again I'm in Q0. I'm getting 0 again, and the stack top is 0. So now I have this combination. Now I can try this option first. So now I can, when I'm here, so I can make it Q1, and I can pop this element from the stack. Now I'm in Q1 and I'm reading 1 again. I'm in Q1 and I'm reading 1 again, 1, and stack top is also 1. So this combination we are getting. So I can, according to this, I can stay in Q1 and I can pop this element from the stack. Now I'm in Q1 again and I'm reading 1 again. So, and stack top is 1 again. So I'm getting this combination again. So according to this, what I can do, I can stay in Q1 and I can pop this element from the stack. Now I'm in Q1, I'm reading 0 and stack top is 0. So I'm getting this combination now, this combination. Now according to this combination, what I can do, I can stay in Q1 and I can pop this element from the stack. Now we have completed the string. Now I'm reading epsilon, I'm in Q0, Q1, I'm reading epsilon and stack top is Z0. So I have this combination. So once I reach this combination, I can pop this Z0 from the stack. And once stack is empty, we are reading epsilon, it means string is accepted. String is accepted. So this is how, if you are not able to accept any string from one option, then you need to go back till that step and you need to use second option. And if by any option if you are not able to accept this string, then you can declare this as invalid string. So this is how NPDA works. So I hope, friend, it would be very much clear. And if you still have any doubt, you can always write to me in comments. I will definitely reply your comment. Thank you. Thank you so much.